This week in CIST 2611, we'll look at encryption fundamentals in Chapter 6. In this chapter, we're going to look at the encryption concepts, the history of encryption and modern encryption methods, and also some simple decryption techniques. Keep in mind that if your data is not encrypted or while it's at rest or during transmission, that data is vulnerable. So no matter how many firewalls, security instruments you have in place, if it's not encrypted, it is vulnerable. So this chapter is going to give you a basic level of understanding of encryption. First, we'll look at the history of encryption. Encryption was originally used in military communications. Originally, it was associated with written communications that include telephone, radio, internet communications. And as decades have went on, it's become more complicated. Some early methods of encryption include a single alphabet substitution, such as the Caesar cipher. In this, you choose some number for which you want to shift the letters of text. So, for example, if the letter is A and you have the number set at 2, then that letter will be C. Rot 13, that's when the characters are rotated 13 characters through the alphabet. The @bash cipher simply reverses the alphabet. So in this case, A becomes Z, B becomes Y, C becomes X, and so forth. In a multi-alphabet substitution, you select multiple numbers to which you want to shift the letters. The rel fits, you take the message you wish to encrypt and you alter each letter on a different row. And I cannot say this word, it's a method of encryption. You encrypt alphabetic text by using a series of different monoalphabetic ciphers selected based on the letters of a keyword. So in this encryption, you do have a keyword that you use that is used to encrypt and decrypt your text. The Enigma was encryption machines used by Germans in World War II. Eventually the encryption was cracked by Alan Turing and a team of British scientists, and researchers said that it helped speed up the end of the war by at least 2 years. All right, so binary operators, for this you take 2 binary numbers and compare them one place at a time. So a couple of these, like in the AND operation, for example, if both of these have the same, both of them have a 1 in the same place in the binary number, then the result is going to be a 1. If it has a 1 and a 0, then the results will be 0. The OR operation says that at least one of the numbers has to be a 1 for the results to be a 1. So if you have a 1 and a 1 that you're comparing, the result will be 1. If you have a 1 and a 0, the results will be 1. If you have 0, 0, the results will be 0. The XOR, so if this has a position of 1 is in one number but not the other, then the result is 1. All right, so if you're comparing the binary numbers and you have 1 and 1, the answer would be 0. If you have 1 and 0, the answer would be 1. So these are some early methods of encryption. We're looking at some modern methods of encryption now. Symmetric encryption. This is where you use the same key. This is a single key encryption. You use a single key to encrypt and decrypt the message, the plain text. The difficulty with the single key encryption is the key delivery. How do you get the key from part A to point B, to party A to party B, without the message being intercepted? With key stretching, this is where you may need to lengthen the key to make it stronger. The key is then put through an algorithm that's going to stretch it, or it's going to make it longer to increase the security of the key. The pseudo-random number generators, this is used to generate the keys for your symmetric ciphers. Public key encryption is going to be just the opposite of the single key. For the most part, you're going to use two keys. You have a public key and a private key. So with this, anyone can access the public key. The public key encryption, you have your private key that's used to decrypt the message. So you would maybe encrypt it with a public key, and then it could be decrypted with a private. Digital signatures. With this is generally going to have some part of your message is going to be encrypted, or where it's signed. So digital signatures is a way that it's used to verify the identity of the sender using the sender's public key. Couple things you need to make sure that you're aware of is to be suspicious of encryption methods that are advertised as unbreakable. There's no such thing as an unbreakable code. Also be wary of, be suspicious of anything that's advertised as certified, because there is no certification process for encryption methods. And anything that's put forth by inexperienced vendors. You want a couple things you want to do is you want to find out what experience the company has that is making the new encryption method. What are the experience of the people that's working with it? Do they have a background in math, encryption, or algorithms? If they don't, have they submitted their methods to experts to have it peer reviewed? Also, are willing to disclose how their methods work so it can be fairly judged. Okay, digital certificate. This is how a lot of times the public key is distributed. We'll say, because this is a digital document contains a public key, it's signed by a trusted party, which is a certificate authority. So it's a way that you can verify whose public key you're using. A certificate authority, these issue the digital certificates. So the primary role of a CA is to digitally sign and publish a public key that's bound to a given user. Registration authority, that's often used to take the burden off the CA by handling verifications prior to a certificate being issued. These act as a proxy between the users and the CAs. They will receive a request, authenticate it, and forward it to the CA. Public key infrastructure distributes digital certificates. PGP certificate is pretty good privacy. Okay, this is a system, it's not a specific algorithm. What they do is they offer digital signatures, asymmetric encryption, and symmetric encryption. This is something that you're often going to find in email clients. Now, with PGP certificates, they use their own certificate format. They will be self-generated, and they're not using a CA. Hash functions, it's a function that takes a variable size input and returns a fixed size string. The value it's going to return is called the hash value or the digest. Three properties that a hash function should have. It's a variable length input with a fixed length output. So no matter what you put in the hashing algorithm, the same size output is going to be produced. It's going to be generated. Hashing is a one-way. You cannot unhash something. Hashing is collision-free. So two different input values do not produce the same output. Now, you do have collisions from time to time. It refers to a situation where two different inputs yield the same output. Hash function should not have collisions. And this is how Windows stores passwords as well. One of the things that you may see with hashing is salt. That's going to be random bits that are used to as one of the inputs to a hash, and this is used to complicate dictionary and rainbow table attacks. All right, decryption is a science, just like encryption is. And once again, remember there is no such thing as an unbreakable encryption algorithm. The strength in decryption and encryption is not in the algorithm. That's going to be known. The strength is going to be in your key. Now, so how long it takes to decrypt information determines on the security. How well is it encrypted with the key? How strong is your key? Now, if you're decrypting message, there is the preferred method. Obviously, having the key and the algorithm would speed up decrypting the message. Now, there are people that's going to try to break your security that's not going to have the algorithm or the key that's going to be used. So there are many different types of methods that they can use. There are many types of utilities on the web that are used to crack encryption. One of these is John the Ripper. We will look at that in the next slide. And sometimes you have administrators that will use different types of password crackers, and they use these to test their own system's defenses. So we'll look at John the Ripper. That's a password cracker. It's popular with both network administrators and hackers. It can be downloaded from openwall.com. It is free. Keep in mind, though, that this program is completely command line based. It has no Windows interface. So this allows the user to select text files from password list and attempt to crack any password. Now, these passwords are stored in different places depending on the operating system. For example, Linux has the /etc/p8sswd. Windows 2000 has a .sam file, which is hidden. You may find that this website be flagged as risky from some antivirus programs. If you open it in private incognito window, you should be able to get in. All right, so cryptanalysis is the science of trying to find alternate ways to break cryptography. It's something that's usually not very successful. It can be quite tedious. There are a bunch of different methods that you go through in your textbook, such as brute force, birthday attack, known plain text, and so forth. Steganography is the art of science of writing hidden messages in a way that nobody other than the sender or the intended recipient should expect the existence of the message. Now, these are messages that are sometimes going to be hidden into a video file, audio file, digital picture, and they're put in their way that the messages themselves do not attract attention. This could also be something that's hidden in an HTML file, for example. You can hide it in the code in the comments, so it's when the user opens the browser, opens the file in the browser, they don't see the message until they go in to look at the code. It's not rendered by the browser. So we have some key terms we need to know. Is payload is the data to be covertly communicated. The carrier is the signal, the stream, the data file, whatever the payload is hidden into. And the channel is the type of medium used. Your textbooks does mention some historical instances of how messages were carried out. It mentions that the ancient Chinese wrapped notes in wax and swallowed them for transport. In ancient Greece, a messenger's head was shaved, the message was written on his head, and the hair was allowed to grow back. In the early 1500s, a book was written on cryptography, and and the message was hidden by having each letter taken as a word in a specific column. Now, in more recent times, you've got computers, but before computers, even in the recent times, there were still other ways to hide messages. During World War II, French resistance sent messages written in invisible ink. Microdots or images or undeveloped film the size of typewriter periods, and they embedded on those documents. And, we had spies in the Civil War, Cold War. We had spies all the way back in the Revolutionary War that used different ways to encrypt and decrypt messages and deliver those. All right, stag analysis is the process of detecting hidden messages. There are a couple different methods that your book goes into, including the raw quick pair method, the chi-square analysis, and also maybe examining noise distortion in the audio carrier files. So that's going to end chapter 6 as we looked at encryption and decryption techniques.